it's not a right triangle. I would say not right triangle. This guy implies, have me a right triangle. So the question you're going to be given is, here's 3 points. Do these 3 points constitute the vertices of a right triangle? And you're going to say yes or no, based on the conclusion you come to in this way. Once again, distance formula 3 times, Pythagorean theorem once. Does it work? Right triangle. Is it not? Not a right triangle. Is that okay? You're going to see one like that. Anything else? All right? All right, one more concept. Hey, we've got a distance formula, right? That's on your 3x5 card. We have one more concept to consider relative to this. That's the midpoint formula. And this is so easy, it's almost insulting, but you're probably ready to be insulted just a little bit. Same thing, I'm looking for the distance, the midpoint between 11, 11, and 3, 5. All right, some of my questions are going to be true, false. Ready for a true, false question? Yes, you are. It's recorded. You're ready for a true, false question? All right, true, false. Every line has a midpoint.
True.
So, for instance, here's a line right here, the x-axis. Where is its midpoint? Right. So you grab hold of this origin, this point, and you say, I know this is the midpoint of the x-axis because it's the same distance that way as it is that way, right? It's the definition of midpoint. What if there's some wise guy in this room, and I have a feeling there are a few who would be discredited. What if a wise guy in this room walked down the x-axis approximately 20 miles and said, no, this is the midpoint of the x-axis. And you say, how do you know? And he says, because it's the same distance that way as it is that way. Oh, by the way, how far is it that way? How far is it that way? How far does the x-axis go that way? Thank you, Evan. How far does it go that way? Or how about if some guy went 17 miles down the x-axis and said, this is the midpoint, because it's the same distance that way, infinite, as it is that way. Infinite. I think we got a problem, ladies and gentlemen. I think you could grab hold of any point on the x-axis and say it's the same distance that way as it is that way. And if you got a million zillion midpoints, I would suggest to you we don't really have a midpoint. Now let me say that statement again that you all said true to. Every line has a midpoint. What should I have said? Thank you. Every line segment has a midpoint. Why? Because it's got a start, it's got an end, it's got a middle. You got to have a beginning and an end to have a middle. Lines that have no beginning and end have no middle point. So every line has a midpoint? False. Every line segment has a midpoint? You got it. That's true. Are you thinking about this? Are you actually thinking about it enough to write it down? Every line segment has a midpoint? That's true. So I got me a line segment here, don't I? It's got a beginning point and an end point. It has end points, so that means it's got a midpoint. And to find the midpoint, it's just so easy. Hey, first of all, the midpoint is a point, which means it has an x and a y. Every point does. X coordinate, y coordinate. That's the nature of points. To find the x value, I simply average the x values. To find the y value, I simply average the y value. Here's what it looks like. First of all, just like on the distance formula, I'm going to call one of these guys x1, y1. One of these guys x2, y2. And once again, it doesn't matter which one's which. Now, how do you average two things?
Divide by 2.
Add them up, divide by 2. Right, that's exactly what we're going to do. To get the x, it's just x1 plus x2 over 2. To get the y, it's just the y's average, y1 plus y2 over 2. Just take the average. Yes, sir?
Couldn't you have just divided the distance by 2?
Divide the distance by 2, I'll get a distance. I don't want a distance or a point. Okay? So good thought. You're right, I'd be able to find the distance, how long the half the line segment is, but I'm interested in the coordinates of the point that's the midpoint. So let's do the midpoint. It's going to be 3 plus 11 over 2, and 5 plus 11 over 2. That's 14 over 2, that's 7. That's 16 over 2, that's 8. So my midpoint of this line segment is 7, 8. Let's see if that looks like a midpoint. Let's see, 1, 2, 3, 4, 5, 6, 7. Woohoo, there it is. When I plot the point 7, 8, it looks like the midpoint of that line segment. So I'm reassured it's on the line and it looks like the midpoint. Everybody okay with that? Find a midpoint, and by the way, this is 3x5 card-worthy information. You know, some of you got this stuff memorized. Good. Most of us don't. So we're going to use our 3x5 card for stuff like this. Distance formula, midpoint. So anytime I give you 2 points,